All right, this lesson is going to be discussing graphs of piecewise functions and evaluating piecewise functions. I'm going to have one main example, and I'm going to take you through the steps to graph them and evaluate different numbers in a piecewise function. So let's start with what a definition of a piecewise function is. A piecewise function is a set of functions that have more than one part, aka pieces. So typically, you might just, in the past, have one function and it's graphed. Each of these functions has some sort of domain restriction set upon it. So it might say like your x in this case is less than 1 for this top function. This x here is greater than or equal to 1 but less than 4 for the middle function. And then this x is greater than or equal to 4 but less than or equal to 8 for this bottom function. And that means that I can only plug in values that meet those inequalities into the functions that you see here. So let's talk about what values that we can plug in into each one. And it makes sense if you look at it from maybe a number line perspective. The top function, 1/2 x plus 3.5 for x is less than 1. That means that anything less than 1, so -2, -3, -4, all of those numbers, including the numbers between them, can go in for the 1/2 x plus 3.5. But everything to the left, because it says x is less than 1, would work. So everything but -1, everything but 1, including 0, -1, -2 would work. But once you hit 1, you can't plug it in because there's no equal sign under it. So that's the limitation for that top one. Okay, that's the restrictions on that. So the middle function, and we'll color code that for blue so we can kind of keep track of them. The middle function, in this case, is x minus 3 squared minus 4, but only for values of x that are greater than or equal to 1, but less than 4. So I can include 1 here because it's got that equal to sign. And I can include 2, 3, but I cannot include 4. So I open circle that. So all the numbers, including 1 but less than 4 and anything in between, would represent that middle function in our example here. So this would be the x minus 3 squared minus 4. And then finally, in our example, the bottom function, this absolute value, or negative absolute value of x minus 7 plus 2, that works for all the values, including 4, because it's greater than or equal to 4, 5, 6, 7, and even 8 in this case, because it says less than or equal to 8 and all the numbers in between. But once it hits that, it's done, okay? So this is going to be the absolute value, or negative absolute value of x minus 7 plus 2. Now notice that this function, and they're all going to have different domain restrictions on them, but the question that you're going to see down here is, what is the domain of this function? And you got to ask, what numbers can be plugged into that function? Are there any numbers that somewhere here would never be able to be plugged in? And the answer to that is yes. Anything at above 8, like 9, 10, 11, 12, in this specific example, doesn't have a spot to plug in because it doesn't meet these inequalities. So my domain would be, because this will go on to the left forever because it says x is less than 1, I can plug in any value of x. Even 4 is covered here, but not there. 1's covered there, but not there. 8's covered here. Any value of x that is less than or equal to 8. So my domain is the x value is less than or equal to 8. And we want to write that in interval notation. So we would say parentheses negative infinity, comma, 8, and then we use a bracket because of the less than or equal to sign. If it was open circle and that was not there, then it would be a parenthesis because it would just be less than. So now let's graph them. And I'll show you how to evaluate the functions in a little bit later. But first I want to look at it from a picture. So we're going to go ahead and graph this. And we'll click on that link one more time. There we go. So the way that you graph a piecewise function using Desmos, I want everybody to open up Desmos and do this with me. So we're gonna have three separate functions to enter into our graph. Now, the name of this entire function is f of x, but due to the fact that we have three different entries, we're gonna wanna name them all differently. So my default is to just say f of x equals the top one. So I'll say 1 divided by 2. Make sure you right arrow and put the x next to it, plus 3.5. To get that limitation for the domain restriction, you are going to enter squiggly brackets. You hit the shift button and then the button right to the right of P. And that'll put in a squiggly bracket, and then you say x, and then you do shift, comma, less than 1. And then you can close that up to finish up that inequality. So squiggly brackets have to be put in immediately after the right, whatever the last thing you typed in for that function. So you'll notice that if I don't have those, that's just going to be a linear function going on left and right forever. With the squiggly brackets, it stops right here. And if you hover over that point, you'll notice that it says 1, comma, undefined, because you really can't plug in 1 to that function, but you can plug in anything less than 1, and it'll give you a y value as a result, okay? Let's look at the second part. I'm going to name this a different function. So even though it's all f of x, I'm going to call this g of x. G of x equals, and then we're going to do parentheses x minus 3, close parentheses, shift 6 to square it, and then right arrow minus 4. Again, that function is stopped. Notice that would be a parabola, but this would fail the vertical line test because you have more than one point representing that. So that's why we cut that off and we make that between those two numbers. So after the 4, you'll do your squiggly brackets again, and you'll say 1, and you'll say less than. To get that equals, you press the equal sign right after it, and it puts the line right underneath it. And then you say x, and do less than 4, and then you close it up. So now that parabola is basically cut off right here at 1, and it stops here at 4, and notice that it also says undefined because it's less than 4, not less than or equal to 4. And then the last one I'll call h of x. So those are usually, you don't usually have more than 3 functions in a piecewise function. Sometimes you just have 2. So I'll say h of x equals, and this is a negative absolute value, so negative, shift, vertical line below backspace, absolute value of x minus 7 plus 2. And this one is a reflected absolute value, right 7 up 2 and flipped over the x-axis. But again, I want to restrict that to the numbers between 4 and 8, including both 4 and 8. So I'll do squiggly bracket 4 less than or equal to x less than or equal to 8, and then close it up. And then you notice that it gets restricted to these numbers. And if you hover over it again, you'll notice that this does give you an output value at 4 because you can plug in 4 to the bottom one. And this does give you an output value at 8 because you're allowed to plug in 8 here as well. The reason that I call these f of x, g of x, and h of x as opposed to just y, or not even putting them in, is because it allows me to make a really quick, easy table for your reference later. So if you hit the Edit List button, you can actually convert these to tables without having this function be wiped off. So I'm going to do that here. I'm going to hit the Edit List again, and I'm going to go down to this one. And then I'm going to do the same thing up here. And so now all of my functions have tables which we can go back and change some values in there so we can get those values later on. So I'm going to go ahead and hide those for now. And what I'll do is I'm going to do a screenshot of this, and there's a couple things you have to look for when you're writing these, if you're ever graphing these by hand or looking at a multiple choice set of answers. Desmos will not always give you all the closed and open circles at the endpoint. So I have to show you how to do that. So I'm going to start by doing a screenshot of this. And we'll put this up here. What you have to add are open and closed circles. And you can get those open and closed circles pretty easily from the inequalities. So if I look at the first function, the 1/2 x plus 3.5 for x is less than 1, that's going to be an open circle because it does not have an equal. So when you get to that point there, that would actually be open. For this inequality, on the left side of the parabola at the 1, it would be closed because of that equal sign. So it looks like that point exists. Let me move that to closer where it should be. But the point here, that would be open circle because it's less than. So that would be an open circle right there. And then finally, since these both are less than or equal to, you're going to have a closed circle for both of those. So that's a closed circle, that's a closed circle. And so the picture of the graph on like a test, or if you were to draw this by hand, would want to have these key features. And one more thing I might add, you do want to put an arrow on these if it's going in one direction forever. So in this problem, I would do that arrow to signify that every value less than 1 is going to be able to be plugged into that top function. So there is a picture of a graph. Open and closed circles, just to reiterate, an open circle is going to involve just the less than or the greater than symbols. So closed circles will be less than or equal to and greater than or equal to because they include them, whereas the open would be those two circles, less than or greater than. So now let's analyze the graph a little bit more using the table and all that good stuff. So first thing is, let me go ahead and screenshot just the graph. We talked about the domain when we were seeing what we could plug in because honestly, you can get the domain just by looking at the inequalities. But the range, you really need to see the graph or at least plug in some points before you can identify what that is. Now on this graph, and all the ranges can vary depending on what shape the graphs are, which direction they open, and there's a lot of factors that go into it. But on this graph, it appears that every y value below this line, remember range is y values, can be included. Now, even though this graph does bottom out at some number, and this graph only is limited to these y values, because of that arrow, that will point downward forever and it'll keep going. So every y value below that line would be considered part of your range. But I don't want to include that y value because, again, it's an open circle. So it's going to be y is less than, not less than or equal to, y is less than, and that appears to be 4. And we're going to back that up with a little bit math later. In interval notation, you would write parentheses negative infinity, comma, 4. And then you would use parentheses because it does not include that. So that would be your range. So I want to go back to the graph and we're going to talk about plugging in some numbers. And that's where the tables come in. This is why I name them different F, G, and H's so we can make a table. So if you go through and click on the edit list again, and I had done that before, but I took them off. Oops. It's a little finicky sometimes. Oh, shoot. All right, I got that back up there. So once you have your functions in there, hit the tables, convert to table. We'll do the same thing for the other ones. Convert that to a table. And finally, for the h of x, convert that to a table. Now the table is really great because what that's going to do is it won't give you the open circles, but at the endpoints it will give you a closed circle, and you can go back and edit the table. So let's look at the red graph, the linear function. You know that any value less than 1 will work. So you see how it says 1 is undefined. But if I were to be able to plug in 1 in there, let's say I made that less than or equal to 1. So you can hover over to the right of the less than and just put it equal. It would give you a point, right? It would give you 1, 4. And that's where the 4 comes from. So anything less than 4, but because it's less than 1, you can't plug in 1, you're not really going to get 4 as an output there. Not only that, but if that were true, it would fail. It wouldn't be a function anymore because it would fail the vertical line test. Okay, both of those ones would give you different outputs, and that's not cool. You can edit a table. So if I want to know what is -3, I could go up to x and press enter, type in -3, go up to x, press enter, type in -4. You can go as far to the left as you want on that. Let's look at the middle function. We know we can plug in 1, but we can't plug in anything less than 1. So 0, -1, -2 is undefined, but you can go past 2. You can go down here and type in 3. That's going to give you -4, and you see how that point pops up on the graph. And then you can go down there and plug in 4. Now it's going to say undefined because it's less than 4. If you want to know what would that number actually be, you could always just modify it and put it equal, and you can see that would be -3. But again, that would fail the vertical line test because you can plug in 4 there, and you would have 2 spots where 4 gets plugged in. So we really got to take that off. So anything between, well, anything greater than or equal to 1, but less than or equal to 4. In fact, you could even go between them. So you could say like 3.5, right? And that's going to give you a value. You could say like 3.6, 3.99 even, right? But as soon as you hit 4, it's going to say undefined. And then finally, the last one, my default table goes from -2 to 2. So it's not showing any points, but we can edit that. If you look at your input values, I would say start with 4. Well, you could start with 3 to show that it's undefined, but then 4 would be -1, 5, 6, 7, 8, 9. Of course, 9 is not going to work because this graph cuts off at 8. But you see that it will give you, is not giving you the open circles, okay? In fact, I got to take this one off here. Well, let me take that off so you're not confused with where that open circle should be. So there should be an open circle there and there like we drew on our graph. And these are just some points, and of course these points would keep going to the left forever if I wanted to add them in there. So again, to get the tables, you got to call them f of x, g of x, h of x. You got to name the functions. I'm going to take them off one more time just so you can see it. You got to hit this edit list, convert to table, and then you can modify the numbers for the input of the table to get to suit your needs. So if the question says, what is f of -5, you could plug in -5 and get an answer. You know, you could try it here. It's going to say undefined because you can't do it because there's no -5 you can plug in, and so on. So hopefully that's helpful for you, and you should be able to work on how to evaluate graphs and pick those apart from your assignment.